All right. Good afternoon, everyone. Thank you for joining me for the Math Professional Learning Series. I am Jen Robitaille. I'm the elementary math specialist at the Maine Department of Education. And we do have Michelle Mayotte on with us today. She is our secondary math specialist at the Department of Education.
Welcome, everyone.
Thank you, Michelle. I will be working on still trying to admit everybody into the session. Again, I've been overwhelmed by the number of people who have registered to join us. It definitely shows that there's a need for professional development around the area of mathematics for our teachers and support staff. If you would, please keep your microphone on mute unless you're sharing or talking. I think that will just be helpful for everybody in the session. I can tell right now we are quickly approaching 300 in our session right now, and more people are joining as we are moving in to the session. So again, thank you so much for joining us today. I just want to go over kind of the way that I've laid out this series. So this series is designed for support staff, though we are welcoming in any other educators, classroom teachers. We're Title I teachers, special education support staff. So we've invited everybody in, and we certainly hope that you can take something away from our trainings. I have set this up for the next 6 weeks, so we will be at the same time and the same location for the next 6 weeks, Tuesday afternoons at 2 o'clock. All the links are the same links, and so obviously if you've made it here today, you found the link and the password in the Google Doc that I shared with you, and so those will be the same links that you'll have for all 6 of the sessions. Feel free to come to one session, come to 2 sessions, come to all the sessions. You will have access to all of the videos as well. I'll be posting those videos in that same Google Doc. I added a new column this morning that said videos coming soon, so you'll be able to see the recorded session. We'll also be posting those recording links to our Department of Education website. So feel free to look for them there, though I find it easier myself to just be able to find them right in that Google Doc. You will receive contact hours. So I know that was questions. Whether or not you are watching the video or you are attending live, you will have the option to get contact hour certificates. So you'll just need to follow the link or the QR code that I will share later in the session and fill out the survey, and I call it a survey. It's really your name, your email address, the date, and just a bit of information about your school. And then those contact hours will be generated. I can only send out 100 certificates. The generator that I use only allows me to do 100 certificates a day. So you may not receive your certificate today. However, you will get it throughout the week. I'll work on sending out each batch of 100 so that everybody will eventually get their contact certificate. So please don't worry if you don't get it today. You will get it eventually. I will make sure that you get it. So we're here today to talk about why new math, right? We hear this term new math, and we're talking about the new strategies that we use. A lot of programs, a lot of schools use specified curricula, and in those curricula they use specific strategies. So that we're going to go over why we use some of those new strategies. So I'm going to share with you my screen, my PowerPoint, and I want to talk about some of the new strategies that we might use. So I hope that you are seeing my PowerPoint screen. And hopefully that's all you see. So think about how you would solve this problem. Okay, you don't need to say out the answers, but just think about how you would solve this problem. 6 times 2 is 12. That's probably a memorized fact that you have. 6 times 5, again, a memorized fact where you can count by fives. So you have 30. 10, again, another memorized fact, 60. But think about if you are given the problem 66 times 5. That's not something that you might think about automatically knowing. We might have strategies in how we would solve that, but it's not something that's necessarily automatic. So let's think about it in a different way. 66 is the same as 60 plus 6. So our math properties tell us that we can multiply 60 times 5 and 6 times 5. And if we didn't know 60 times 5, one of the strategies that students are learning these days is to use that 6 times 5. 60 is 6 tens. So 6 tens times 5, 60 times 5 is 30. 6 tens times 5 is 30 tens, or 300. So 60 times 5 is 300. 6 times 5 is 30. So I can then add those together. 300 plus 30 is 330. So that's a new way to think about it. In our typical standard algorithm that we see, this is often how we would solve the problem. We would think about it, 66 times 5. We would multiply 5 times 6 is 30. We put the 0 down in the ones place. We carry that 3 into the tens place because really it's 3 tens. And then we multiply that 5 times 6, but it's the 6 now that's in the tens place. But we think of it as 5 times 6 is 30. We add that 3. And we get 33, we write it down in that hundreds and tens place. So we get 330. It's this list of steps with no meaning for place value. And so if students can't follow that list of steps, they might really struggle. So it's just a way to think about solving these problems in a different way. So let's think about a different type of problem. Let's think about if we were to do subtraction. 1,000 minus 989. Now, if our students were given this problem, they might think about it as I've got to set it up and I've got to make some trades. So they cross out all those zeros, they make trades for tens, those tens then become nines. The 0 would become a 10 again, we cross that out and that becomes a 9, and then we have 10 in the ones place. They make all these trades because they're not subtracting from 0 in this standard algorithm. We know that we can subtract from 0, but we end up with negative numbers, and so in this case, that's not what we would do if we're following this list of steps. So we end up with 11. So we have that 10 in the ones place minus 9, we get 1. 9 in the tens place minus the 8 is 1. 9 minus 9 is 0. It's this list of steps, again, with no meaning for place value. And so if students struggle making those trades and with place value, they may not get the correct answer. So if we think about this in a different way, we have an open number line. That's what this model is called. It's an open number line, so the number line doesn't start at 0. In fact, I'm actually going to think about 989 as a distance, as a difference. From 1,000 backwards to 989, that is a distance, and that's what difference, when we subtract, that is what that means, is that distance. And so a student can either count up, or they could count backwards on this open number line. And in this case, I'm modeling starting at 989 and I'm counting up. And I'm going to make this jump of 1 first, because I like that 990 is an easier number to work with than 989 and jumping 10 more there. So I'm actually going to add 1, get to 990, and then I'm going to make a jump of 10. So I've made this small jump of 1 and I've made this larger leap of 10 for a distance of 11. So I've put in some place value understanding of what, and some meaning behind what subtraction is. Subtraction is that difference between two numbers, or that distance between two numbers, and students can visualize this on the open number line just to make sense of the problem, rather than following that set of steps and having to make all those trades. I would hope that a student could look at those numbers, 989 and the number 1000, and know that those were 11 apart rather than having to go through all of these steps of making trades, because I have some number sense built in. Okay, so I want to share with you a video that gives another example of multiplication. Let me see if I can share. You should be seeing a video.
If there's one question that parents ask me, just more than just about any other question, it is, why are they teaching math so much differently now than they did when we were growing up? Why don't they just teach the standard algorithms? Why aren't they helping kids just get to the answers and get them quickly? And why are they spending so much time on these things that seem so inefficient? And I have an answer to that question, and I'll start by saying, we have decades of research that shows that teaching people just to memorize algorithms and execute procedures hasn't worked. It's worked for a small group of people, but for most people, they don't like math, they don't enjoy math, they don't think they're good at math, they have a really hard time with it because no one taught them to understand the concepts and why we're doing what we're doing. We didn't teach kids how to think, we just taught them how to do and execute in this misguided idea that we just need them to get to the answer as quickly as possible. So let me start with a multiplication example, 2-digit multiplication. And as students, we may have learned it, or you've probably learned it, to do the standard algorithm. Line your numbers up vertically, and then start with the ones column and go. 4 times 5 is 20. We're not allowed to write the whole 20 here. We just write the 0 and bring the 2 up there. So that's the first place where we're doing something that is kind of weird. Then we do 4 times 4, which is 16. We have to remember to add in the 2, which is 18, and we place that there. Again, we haven't really told anyone exactly why we're doing that, but that's how you execute the procedure. Then you put in your, what I used to call the placeholder 0, so you put a 0 here. And you move over to this number, and you do 2 times 5 is 10. You only write the 0, and then we don't need this anymore. We carry a 1. And then 2 times 4 is 8. We have to add in that 1, which is 9. And then we add these all together, 0 and 0, 0. There's an 8, and here's 10. And it's 1,080. Hopefully that's right. Now, these days, before we teach kids the standard algorithm, we might teach them what's called partial products, where we're going to help them see what's going on with place value in these problems. So again, we'll start with 4 times 5, which is 20. And we'll just go ahead and write that whole thing right here, 20. That's the first part of the problem. The next is we're going to do 4 times this 4. But we're teaching students that this is not a 4. It is the digit 4, but when it lives in this column, it actually represents 40. 4 times 40 is 160. And you'll notice this is the 180 that was there, so there's nothing really different going on here, just in how I write it down. Then I have not 2, but 20 times 5, which is 100. And I have 20 times 40, which is 800. And you'll notice again, these two here are 900, that's just what we had there. We'll add them all up, and we will get 1,080 again. Now, you might say, well, this isn't very efficient. Look how many steps that was. Look how many things I had to write down. And you're right, but we now have a conceptual understanding of place value. We're not having to write numbers up here and scribble them out, which is a bit confusing. And we're still getting the same result. So we'll teach this to students first so they understand what's going on. Later we can teach them the shortcut so they can save a tiny bit of paper to get to this answer. But there you go. And then we might even give them a visual picture of what's going on. When you multiply two numbers, you can think of that as the area of a rectangle. And this rectangle would be 24 units on this side and 45 units on that side. And if I break it up like this, and I imagine this to be 40 and 5, and this side to be 20 and 4, then I can compute the area of these 4 little internal rectangles. This one here is 20 by 40, which is 800. This one here is 40 by 4, which is 160. The little one is 5 by 4, which is 20. And this other one, vertical one here, is 5 by 20, which is 100. And you'll notice those are all the same numbers that we had over here. Okay, so this is the same thing, but now I'm giving you a visual picture of what's going on. And it turns out that this picture becomes in really handy when we get to algebra, because we can replace these with variables and still be able to figure things out. But that's probably an aside for another time. But now I have different ways of conceptualizing what's going on before I get to the standard algorithm. This is why we're teaching math so much differently now. And there is research that shows that when you give people a conceptual understanding of what's going on, it really helps them get answers that we want them to get and explain their thinking, and also look for better ways to do things, because the standard algorithms are not always the best way to do things. So I hope that helps you as a parent see why math is so much different now. The other thing that is a corollary to that first question is, I don't know how to help my students with the math because it's so different. And these homework assignments look so confusing because I've never seen anything like this before. And I think that question kind of proves the point of, if you learn math in a way where it was always this way, always follow these steps, this is how it works, then you never learned to have flexible thinking, how to take numbers apart and put them back together, how to find shortcuts, how to be creative in mathematics. And that's where some of the beauty, most of it actually, lies in mathematical thinking. Isn't in executing algorithms, that's kind of boring. But learning how to think and solve problems is a lot of fun. And so teaching math this way also can bring back a lot of fun to mathematics.
Okay. 1, 2, 3, 4.
All right, so hopefully we're back. You can see me again, and not my screen. So something different to think about when we're thinking about how we solve and how we're helping our students solve problems. We all grew up learning the standard algorithm. It was a set of those memorized steps, but we've come so far in our understanding of needing to teach children about conceptual understanding versus just procedural understanding. There's a place for procedural understanding once we get to that point where we understand what we're doing with those numbers. So I want you to think about the examples that I shared and the example from the video. And I'm going to actually break you out into breakout rooms, and there'll hopefully be about 10 of you in each room. And I'm going to have you just quickly introduce yourselves, maybe like which school you're at, and then talk about the learning that you just saw, or some new thoughts maybe that you have around the different types of examples that we just shared. So I'm going to do these breakout rooms. If you give me just a moment, you will see something pop up on your screen inviting you to a breakout room. So you should have seen something pop up on your screen. Feel free to click that, and I'm going to give you about 10 minutes in your breakout room. So if you're still in this room, you should have gotten a message to attend a breakout room. So you want to follow that link and it will take you to the breakout room. So welcome back from the breakout rooms. Hopefully you found that useful or just a way to share. I know some folks were saying they hadn't seen the breakout rooms before, so just a new tool in Zoom. Again, we can do it randomly or we can do those breakout rooms assigned if I had specific groups that I wanted to make in Zoom. So any thoughts about these new strategies that anybody wanted to share that maybe they talked about in their group? You will have to unmute yourself.
The one thing that I pointed out when we do something using so many digits, especially keeping the numbers aligned for students, I came across this, I don't even know how I did it, but just take a piece of lined notebook paper and turn it on its side, and that will keep their numbers in line.
Nice strategy. So we will be talking about specific strategies for the next 4 weeks. So next week, our focus is going to be on addition strategies. Then the week after will be subtraction strategies, and then multiplication strategies, division strategies, and then just a kind of all around routines and the way that we support students will be that final week that we meet. You can attend, like I said in the past, you can attend just the ones that you feel pertain to you, but feel free to come to all of the sessions. I appreciate that if you teach only addition and subtraction, you don't work with students on multiplication and division, you might like to know how the addition and subtraction strategies link to the multiplication and division strategies. Just like if you focus mostly on multiplication and division, you might like to see how the addition and subtraction strategies link to those multiplication and division strategies. So I'm going to share some of that each week. Each week I also will share a game and a routine that you can do with students. And these games are, that I'll share, have to do with like a deck of cards or some dice, things that students might actually have at home, and also something that you could play with a student in our remote learning session. So if you had a student that you were Zooming with, you might be able to each have your own deck of cards and play a game that way. So I will share those strategies as well over the next weeks. So before we can focus on addition, subtraction, multiplication, and division, we really have to back up to how students learn about numbers and counting, right? Because that helps support when we start with addition and subtraction, we need to know just that students have one-to-one correspondence. We need to know if students can compose and decompose numbers, because when we do some of our addition and subtraction strategies, or even multiplication and division, we are working with number sense and breaking apart numbers, and we need to know that students know how to do that. We also, combinations of 10, we want to know that students know how to do that because that's very important in our decomposing numbers and breaking them apart. And we want to make sure that we are building number sense for kids, because if they have holes in their number sense, it's going to be a challenge for them to move forward with their computation and with their the operations and the strategies that we're sharing. So I'm going to actually share a video with you from Graham Fletcher. He is kind of one of our math gurus. He has a website called gfletchy.com is his website. And on his website, he shares different progression videos, and I'll be sharing those progression videos over the course of our sessions. But today the video that I'm going to share with you is about early number and counting. So it's about how our earliest learners start to make sense of numbers and how they start to organize their thinking around counting. So I'm going to share that. So I'm hoping that you are seeing my screen. I want to pull up the chat box. And let's give this a go.
Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these two hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6, but you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a hundreds chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies, and on the bottom here with the rec and rec, we have a producer of 8, and they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word, but all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subitizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subitizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
Let's continue the conversation on Twitter.
So I know often we don't think about how students learn to count and about number, especially if you're working in the mid to upper elementary grades. We don't think about what students did back in pre-K and K and even in first grade around learning to count and put together and take apart numbers. And when we think about that decomposing of numbers, it's so important when we get into addition and subtraction that students understand how to break numbers apart, especially by place value. And so that's where if we have students who have gaps at the earliest levels of learning, and we're trying to teach them something that connects to a place where they may have a gap, we're struggling with those learners. And so we're going to focus on each of those operations over the next coming weeks. So I see that people are sharing in the chat box some of the programs that they're using, and I hope that you will see in our upcoming weeks that some of the strategies that we teach are strategies that you are finding in some of those programs that you are using. at this time, are there any questions about this series of math trainings that we're going to do over the next 6 weeks, or questions about the math that we saw today? And if you want to just put them in the chat box, we'll monitor that chat box. Or if anybody wants to ask their question out loud, that is fine as well. The link to the last video, I will grab that for you. So the link that I shared in the chat box is the gfletchy.com, but that takes you directly to the progression videos. And the video that we watched today was called Early Number and Counting.
Do you have a kind of like a cheat sheet for all the terminology? Like, I know the concepts, but I had to be looking up the subitizing and the cardinality and those kinds of things that technical academic people use.
Yeah, I will share in our chat box the Learning Trajectories site is actually a great site for either videos or learning about the progression and the terminology and what that terminology means. I will find that site for you. And it's built off, the site that I'm going to share with you is built off of Doug Clement's work, Building Blocks program. I like this site because it's so specific. And if you create an account, you can actually, it's a free account that you can create. You can actually go into small lessons that work specifically on those skills as well. And that is the learningtrajectories.org website. And again, you can create a free account there. I see someone else has shared about the YouTube videos, Common Core Math Explained. That was the first video that I did share, was the video about the Common Core Math Explained. That was on YouTube. Yeah. Any other questions?
That learning trajectory site, the website just disappeared.
Oh, I will share it again.
Thank you.
And what about the strategies that you saw today? Are you familiar with open number lines, or we looked at kind of using partial products when we multiply parts of multiplication products? When we looked at multiplication problems and multiply parts of each part and then add them together, that's partial products. And that's a common strategy that you might see. And yes, someone is asking about the contact certificates. I'm actually going to pull up my screen again, and I'm going to share with you the link to so to get to the survey, you can either type in this survey link, or you can scan this QR code. And I also will work to get the survey link put in the chat box. So I just put the bit.ly address in the chat box. So you can copy and paste that into a web browser, and that should bring you up to the survey. But if you have, I know it works with an iPhone. I'm not sure if it will work with a non-iPhone, another type of smartphone. But if you actually open up your camera app and you try to take a picture of the QR code, it will ask you if you want to open that, and it will open you to the same bit.ly link. And it's a Google form where you can put in your information, and I will collect names and email addresses for everyone who attended, and I will make sure that you get a contact certificate. Great, someone says it does work with Android, great.
Yeah. The survey link is not on the DOE webpage.
Right, because you needed to either be part of the session or watch the video in order to get the survey links. So if you go there, again, I will get out contact hour certificates to everyone. It just may take a few days. Like I said, I can only send out, my generator will only generate 100 every day, and so I will work to get those out over the next 3 to 4 days. Everybody will get them.
Excuse me, Jennifer.
Yes.
I'm on the survey link that I'm seeing. Are you telling me I need to click on this to do something with
Yes.
it? Or am I good for today?
Nope. If you click on this link, so I will share it again in the box. You want to copy and paste that. So if you click and highlight it and copy and paste that into whichever web browser you use. So into either Google Chrome or into Explorer, it will pull up a Google form. And when you get to that Google form, you will put in your name and your email address. And what that does is it collects them for me, and I will generate a certificate for you. So you have to do something with it so that I have a way to send out a certificate to you.